This is Miguel Montalban, and this is my video submission for Lab 7. In the first exercise, we were shown a non-inverting amplifier circuit, and we are asked to find the gain. We performed this analysis on paper, analyzing the voltage of the amplifier and our knowledge of voltage divider. We can find the gain of the whole circuit. Gives an output of 1 plus resistor 2 divided by resistor 1. Okay, so for exercise number 2, we have a voltage follower circuit. This is performed by using operational amplifier that would work as a unity gain or buffer, and then we have the potentiometer to vary the voltage in. Looking to the Arduino code, what we did was reading the values for each pin, then place all that together in a string so that it's easier to get in the processing code. If we run this, we'll see that at the beginning the three voltages are at the same level. When we vary them, we see that they go straight to the same voltage until we go very up that the would start to saturate. When we get down to a value close to 2, it should stop following the voltage in. Okay, and what should happen is that it stays at 1.9. So this is because Arduinos are only between 0 and 5 volts, and once it gets around 1.9, it gets saturated. My operational amplifier seems to be wrong. I have attended to several office hours with Professor Krieg and teaching assistant Kathleen, and they have told me that the wiring of the circuit is perfectly well, and the code as well. So there must have been an error with my operational amplifier since I'm not using the same as in the practice. So even though the values in the intermediate levels are okay, once it gets down, it doesn't behave as it should. Phase 3, we were building an inverting amplifier circuit. For doing so, we were placing a resistor of 10 kilo ohms between the inverting input of the amplifier and the voltage output of the amplifier. And then for the non-inverting input of the amplifier, we're using a voltage divider to maintain that value at 2.5, which would be like a ground to our circuit. Coming to the Arduino code, we didn't change anything. We just added another variable for the non-inverting input, the voltage plus of the amplifier. If we run this in processing, we would see that at the beginning, if we stay closer to the ground, which is at 2.5, the voltage out would start inverting. This is because of the minus 10 gain. And then if we go up, it would invert it in the other way. If we go to values too high or too low, it would not vary because of what we explained of the Arduino just having between 0 and 5 volts. So this would only work for really small values. As we see here, we were inverting it, but we were very close to the ground. So it would be varying the voltage output between around 1.5 volts and 4 volts. So for exercise 4, we are in the case of an integrating amplifier as the one we see on this figure. What we can do in order to solve this circuit and find the gain is apply the current Kirchhoff law on node 1 we see here. We also see that the voltage plus is grounded, so that would mean that the voltage at this node is 0, so we can take that away. And then solving for the out, we find this equation, and if we put it in with respect to time, we will have to add the integral, and then getting the gain from here, we see that it's minus 1 divided by RC. Given RC, we find that the gain is minus 21.3. So going to our circuit, what we changed was the negative feedback resistor by a capacitor of 10 microfarads, and the resistor between the potentiometer and the inverting input is now 4.5 kilo ohms. The non-inverting input, it's kept at 2.5 volts again. Going to our code, we didn't change anything, and same happens in the processing. If we run the code, at the beginning, we'd find for values close to 0.5 ground, the voltage out is getting inverted, but now it's getting to higher values due to the higher gain of minus 21. If we get too low, it would just stay at that value. And now if we come to the other side, we see that it will start inverting until it touches the bottom or its top bottom due to the 0 to 5 volts of the Arduino. So that would stay like that and wouldn't change. Only until we are very close that it would start changing. And if we do massive changes, it would increase until 5 volts.